All right, so our last section on logarithms is 7.4. Okay, and basically we're going to use all the properties we learned Monday and Tuesday to solve equations. Okay, so the properties we can use that we know. We can change from exponential form to log form, okay, or the other way. We can take logarithms and combine them. Okay, we did that yesterday. Or we could separate them, but usually combining is the way we're going to do it today. And we can use the calculator. Okay, so if we need to, we'll use the calculator. Okay, so our first example says 2 log base 5 of x equals log base 5 of 9. Now, if these logs were on the same side, my first thought would be to combine them. Okay? 2 logs with the same base, it's easier if we put them together. But they're on separate sides of the equal sign. Okay, so we're going to leave them on separate sides. Okay, so no combining. But there is something I can do on the left. Okay, using a rule, I think it was rule 3 in the properties of logarithms. Had to do with this number in front. Yep. Yeah. Okay, you can move this back as an exponent. Okay, so that becomes log base 5 of x squared equals log base 5 of 9. Okay, what already matches on the left and on the right? The base 5 and what's attached to that? The word log. Okay, those two things already match. So it's not that they cancel out, but since they already match, I don't need to focus on that. I need to focus on what doesn't match. Okay? Somehow I need to make x squared match 9. If these bases didn't match, okay, we'd have a problem. Okay, this would be a lot harder. But since the bases match, just ignore that part. Focus on that. Okay, how would you solve that equation? Yep. Take the square root, and what would you get? 3. Okay, let's check it. If I plug in 3 for x, I get 3 squared is 9. Log base 5 of 9 equals log base 5 of 9. So I have the same thing on both sides. So I made them match. And that's it. Okay. Any questions on that one? All right. So let's take a look at this one. Okay, a lot of what we do today that I think made people a little confused in the last class has to do with Algebra 1. Okay, so if you don't remember your Algebra 1 stuff, like factoring, that kind of stuff, these kind of problems are going to be a little tricky. But if you remember how to do Algebra 1, there's only 2 things we have to do here that are what I taught you. The whole rest of the problem is going to be Algebra 1. All right, so we got 2 logs on the same side of the equal sign, and they have the same base. What can we do with those? Two logs on the same side with the same base. Mm-hmm.
Put them in the other form.
All right, so we're looking at this one. We've got 2 logs on the same side that are separate. Okay, so what do we usually want to do? If we have 2 logs that are separate, we can take and...
I was going to say you have to change it to multiplication. So you do
Yeah.
log for x plus 3 times the 2 minus x.
Yeah, so we're gonna combine these 2 logs together into 1 log. Okay. When we combine it, do we change the base? No. But this plus sign tells us how to combine them. Whenever we have a plus sign, we're going to multiply it together. All right? And this time, when you multiply x plus 3 times 2 minus x, how do we do that? Yeah, some people call it FOIL or distributive. Okay, what I'm going to do is I'll distribute it. I'm going to write the answer up above, but then I'll put the final answer down below. Okay, what's x times 2? 2x. Okay, x times negative x. Okay, 3 times 2 plus 6 And what's 3 times negative x? Okay, so usually when we write this, we like to put the highest exponent first. Negative x squared. What's 2x take away 3x? Negative 1x. And lastly, my plus 6. What's that still equal to? Still equal to 1. Right, so now we've at least taken 2 logs that were separate, combined them into 1. Well, there's no numbers in front to put back as exponents. There's no more combining. What's the only other thing we can do with an equation that's in log form?
Change it to exponential.
Yeah, change it to exponential. What is my base? What is that? 4. Okay. What's my exponent? 1. And what goes on the other side by itself? Yeah, my negative x squared minus all that. All right, so negative x squared minus x plus 6. Okay, the rest of this problem is algebra 1. Okay, it's nothing that I've explained to you guys this week. Okay, this step and that step are the only 2 that I've taught you how to do. All right, one thing I'd do, let's just do the power out. What's 4 to the first power? All right, so we can do that. And anybody remember what kind of equation this is called when your highest exponent is a 2? Begins with a Q. Yeah, this is a quadratic equation. Okay, several ways to solve a quadratic. Factoring, if it works, is the fastest. You can use quadratic formula if that doesn't work. But we'll try factoring first, and hopefully that works. Okay, if you want to factor something, you have to get it equal to what number? Anytime you want to factor, it's got to be equal to, what is it? 0. It's got to be equal to 0. So I need to move everything to one side. Okay, I'm going to take all these terms and move them to the other side. Okay, you might say, well, why don't you just subtract the 4? It's a lot easier to just move that one thing than move all 3. Well, the problem is I don't like that. Okay, whenever we're going to factor, we don't want a negative in front of x squared. That makes it a lot harder. Okay, so the way I'm going to avoid that, I'm just going to shift everything to the other side. Okay, how am I going to move negative x squared? Yep, I'm going to plus x squared. How am I going to move negative x? I'm going to add x. And how am I going to move the plus 6? It's minus 6. Okay, and whatever we do on the right, we got to do on the left. So plus x squared plus x minus 6. Okay, all on the left. Okay, what's on the right-hand side now? 0. And I've got positive x squared plus x, and I had a 4, and I'm subtracting 6. Negative 2. All right, so now what's our first step when we try to factor? We have to draw something. Remember, George?
Don't you multiply the first and the last one, and the middle has to add up?
Okay, so yeah, you're kind of on the right track. We were going to multiply 2 things together, but they have to add to something else. But I have to write something here first. Parentheses. Right? Anytime you're going to factor, you always start with that. Okay? And now, what are my first 2 terms going to be? Yep. I have a positive middle and a negative constant. So what are my signs going to be? What are my signs going to be? Yeah, it's one of each. Okay. So make sure you review that for factoring if you're not sure about that. Now I need, as George was saying, 2 numbers that multiply to give me 2 and subtract to give me 1. What is it? Yeah, 2 times 1. Now, it makes a difference if we do 2 times 1 or 1 times 2. Which way do I want to do it?
+2, negative.
Yes, +2, -1. Let's check. X times x is x squared, minus x plus 2x. A -1 plus 2 is a +1. Yep, and 2 times -1 is -2. Okay, so now we factored it. And now the last step, if you multiply something times something and get 0, what's the only way that can happen? If you multiply two things together and get 0. Yeah, 0 had to be, you had to multiply by 0 at least once, maybe twice. So either that has to be 0, or that has to be 0. Okay, what would make my first factor 0? -2. And my second factor? 1. Okay. Now, when we're working with logarithms, the only thing we have to do is double check to make sure we never take the log of what kind of number. I said logs always have to be positive. Okay? So we have to check to make sure you're not taking the log of a negative number. If you are, if one of these answers causes you to take the log of a negative, we're going to cross it out. Right? So let's start with x equals 1. Okay, 1 plus 3, is that positive? Yep, that's fine. 2 minus 1, is that positive? Yeah, so we're good there. Let's try -2. -2 plus 3, is that still positive? Yep, that's fine. How about 2 minus -2? Yes, that's positive. Okay, so both of these answers work. Okay, 3 things that could happen. Both, when you're all done, both answers you have could work. Both answers might not work. Okay, they both don't work. And then one works and one doesn't. Okay, and this was the case where they both worked. Does anybody know the symbol that you use if both answers didn't work? It's the symbol for no solution. Anybody know what that symbol is? It's not an equal sign with a line through it, but it is something with a line through it. Yeah, a circle with a kind of a line through it like that. Okay, that symbol means there's no solution. Okay, or empty. It also means empty set. Okay. I don't want to use that on this one because we had a solution. Okay. But that's, I'll just write this down. Symbol for no solution. Anybody know what that is? It's a letter from the Norwegian alphabet. So it's a letter from their alphabet. Why they picked that symbol? I don't know. Okay. Why'd they use this to represent 3.14? I don't know. They just did. All right. So if you get a problem you can't solve, no solution. Okay. All right. So this problem, not as long as the last one. Okay. This one's pretty much one step and then a calculator. Okay. What's the only thing I can do with this equation? Change it to exponential. Okay, if that doesn't work, we're stuck. Okay, so George, can you change it for me?
It'd be 3 to the square root of 9 equals x.
3 to the 9th? Yep, I thought you said square root. Okay. Equals x. That's it. Okay, if this number is small enough, we can do it out. 3 to the 9th, it's pretty big, but it's not huge. So it's 19,683.
So we're gonna have to actually figure them all out and simplify them.
If it's small enough, they might have you do it out. Okay, it'll be a multiple choice.
There.
Yeah. Okay. the testing authority.
Yeah.
If it was a number like 3 to the 50th power, no, that's way too big. Okay. Any questions on how you type that in case they have you do it out? Okay. All right, this problem is very similar to the very first thing I showed you this week. If you go back to section 7.2, first thing I did is I gave you guys some problems like this. I said 2 to the x equals 8. 2 to the x equals 16. I gave you ones that were easy to do, because 8 is a power of 2, 16 is a power of 2. This one's not as easy, at least to do in your head. Okay? If I tried 3, what's 2 to the 3rd power? 8. That's too big. What if I tried 2 to the 2nd power? What's that? 4. That's too small. So the answer here for the exponent is somewhere between what two numbers? 2 and 3. 2 squared is too small, 2 cubed is too big. Okay? So we'll get the decimal, and let's see in the end if it's between 2 and 3. Okay, there's really only one thing I can do with this equation. What's the one thing I could do here? Yeah, change it just like we did the last problem, except this time, instead of changing to exponential, change it to log. Okay. Anytime you've got a variable as an exponent, remember, logarithms solve for exponents. Logarithms are exponents. Okay, what's my base? 2. What's my argument? 5. And I just said it, logarithms always equal exponents. That's it. Okay, now what if they wanted us to type that in? Can we type a base 2 in with just one button on the calculator? No. How can I rewrite that so I can type it in? So this was the very last thing we did yesterday. Yep.
Remember the exact number, is it log 2 over log 5?
Keep it pretty much the way you see it.
Log 5 over log 2?
Yeah, log 5 over log 2. Now, what base are you using there? 10. Okay. So now we've rewritten it as a base we can type in. If you want to know what it is as a decimal, we know it's between 2 and 3. Well, this is how you type it in. Okay, log 5 divided by log 2. Okay, and that's what we expected, is about 2.32. Okay, any questions on typing that in? Okay, type it in just like that. Okay, questions on this problem? Yeah.
So which would be the answer on the test?
If they wanted it as an exact answer, you would leave it just like that.
Okay.
If they say round your answer off to 2 decimals, like that. Okay, they're both correct depending on the directions. On the test, I'm going to have a mixture of both. Okay. Yeah. Anybody need me to do this one? 2 to the x equals 5, 3 to the x equals 24. It's pretty much the same thing. Any questions on how you do that one? No? Okay, so I'm going to skip over this one. All right. What's different about example 6 compared to example 5 and example 4? There's an 8. Yeah. If you want to change this to log form, you have to have the number with the variable by itself. Number with variable by itself. Get that by itself. Right, so how would I get this 8 on the other side? Divide by 8. Okay, this is multiplication. Use division. And now rewriting it in log form, what's, Amanda, what's my base?
3.
Yeah, my base is 3. Logarithm always equals your exponent. And Brianna, my argument? 5 divided by 8. This time I'm not going to find the decimal. Okay, I'm just going to leave it like that. Questions on it?
Oh, you crossed it out. I was like, where'd the 8 go?
Yeah, we divided by it. Okay, so if you want to change to log form, you got to have the number with the variable as an exponent by itself. Questions on that one? All right, example 7. This is not a good one to do if you're at the very bottom of your page. Okay, so leave a little space. It doesn't look that bad, and it really doesn't use anything except Algebra 1, but it ends up being a decent amount of writing. Okay, so this will be the longest one we do. Well, it's not like it's going to take 20 minutes, but it takes a little longer than some of these quick ones. All right, what makes this hard to solve? Like if you showed this to somebody in Algebra 1, what's challenging about that? What about the exponents? They have variables. Okay, if you had a problem like 5 times x minus 2 equals 3 times 3x plus 2, it's super easy. Okay, just do your distributive property and solve it, get all your x's on one side. Now, what I'd like to do is be able to take these exponents and put them in front. Okay? That's basically what I just did here. It's like I took them as an exponent and brought them down. Can I just do that? Can I just take exponents and put them in front? Brandon?
No, you need to get log.
Yeah, you got to have the word log. Okay, if you want to take exponents and put them in front. So that's exactly what I'm going to do. I'm going to take the log of each side. Okay, everything else is going to stay the same. Just take the log of each side. Now, because I have the word log, what can I do with my exponents? Yeah, now I can put them in front. Okay, so we've got x minus 2 times the log of 5. And I've got 3x plus 2 times the log of 3. Okay, any questions so far? All right, now the log of 5. Okay, I'm not going to write this down, but I just want to show you what it is. It's just a number. Okay, that's all it is. Okay, I'm not going to write it as a number right now, because if I round it off now, it's going to mess my answer up at the end. Okay, so I'm going to leave it as log 5. Okay, log 3. It's also just a number. Okay, so it's almost similar to the property you'd use here. When you have just a number on the outside of parentheses, what do you do with that number? How do we simplify that left-hand side and on the right-hand side? Same property. Yeah, it's the distributive property. Okay, any question on that? Okay, so all you have to do is take whatever your number is on the outside and distribute it. Okay, when I distribute, there's not really much I'm going to do. It's just x times log 5. That's all I'm going to write. Minus 2 times log 5. Again, it might look confusing, 2 log 5, but that's just a number. If I really wanted to, I could get the decimal. Okay, but I'm not going to do it because it's going to mess up my answer. Okay. Who can tell me what I'm going to have on the other side doing the same thing? Oh, Cooper?
3x log 3
Yep, let me write that. 3x log 3.
plus 2 log 3.
Good. Plus 2 log 3. Again, if I really wanted to, I could change 2 log 3 to a decimal. Okay, but I'm not going to at this step. All right. So now we've got an equation with x's on both sides. Okay, back from algebra 1, what do we usually like to do with all our x's? Yeah, we like to get them all alone eventually, but at least the first step is to get them all together on one side. Okay? So you could do it two ways. Either put the x's on the left or put them on the right. I'm going to put everything on the left. Okay? So how would I move this to the left? Subtract it. And subtract it. And now, if I've made the decision to put everything that has an x on the left, I need to put everything without an x on the right. So Bruce, how would I move negative 2 log 5 to the other side? I'm going to add it. So that's gone. And there's not really much we can do to combine like terms. Okay, these are different arguments, so we're just going to write it up. X log 5 minus 3x log 3. Okay, and the other side is just a number. Okay, it's just one giant messy number. It's 2 times the log of 3 plus 2 times the log of 5. Again, I've said this before. At this point, I could turn all of that into a number if I really wanted to. I could type it all in. But I'm not going to because it would mess up the final answer. Right, so we got 2 steps left, and then we'll be done. Okay. On the left-hand side, how many places do you see x in? It's in 2 different places. It's here, and it's here. Anytime we have the same thing written twice, we can factor it out and just write it once. Okay, so now we're going to go from having x's in 2 spots to just 1 spot. If I take x away from the first term, what do I have left? Just log 5. And if I take x away from the second term, what do I have left? Negative 3 log 3. Okay, and the right-hand side, just keep it exactly the same. The only thing that's really makes this look complicated is writing the word log. If you took the word log out of every part of this, it would look a lot simpler. But don't let the word log trip you up. Okay? This whole thing is just a number. This whole thing is just a number. Right? So this would be similar in algebra 1 to having something like x times a number equals a number. That's not our problem. I'm just showing you something that's similar. A letter times a number equals a number. The last step is just to get this number on the other side. Okay, so how would I get this number on the other side? Yeah, divide by that number. If you want to move a number that's next to a letter, you divide by it. And that's our last step. So that's all gone. And we get log 5 minus 3 log 3. Okay, so if you want me to write it nice, so we just have x by itself. X equals everything we just wrote. 2 log 3 plus 2 log 5. And then log 5 minus 3 log 3. Okay, generally this it's not the kind of problem that if you just look at it one time, go through it, it's going to make sense. Okay, this is a good one that if you have a chance, go back and watch it again. And I think the second time you see it, it makes a lot more sense. First time through is a little rough. Now, if they wanted the decimal for this, I would not try to type all this in one step. Okay. How come I shouldn't try to type all that in one step? What do you think is going to happen if I do? Well, Tommy, what do you think?
Error?
What's that?
Error?
Yeah, you're probably going to mess something up. There's too many logs, there's a plus, there's a division, minus signs. Okay, so if they really want you to find the decimal for this, I would type it in 2 steps. Okay, first thing I would do is just the top. 2 log 3 plus 2 log 5. Okay, that's pretty easy. Okay, just type in the top, get that answer. Okay, then type in the bottom separate. Log 5 minus 3 log 3. Okay, that part's pretty easy. So now we got the top, we got the bottom. Just take those 2 numbers and divide them. Then we could get what this equals. All right, 2.352 divided by negative 0.732. Right, so if you think you can type the whole thing in at once and not make a mistake, go for it. Okay, just type it in. When things get this big, I usually make a mistake, so it's up to you. Okay, and chances are, if it's this messy, I'm not going to have you round this off anyway. I'm just going to say leave it like that. Just stop at that step. All right, questions on that one? Okay, definitely a tricky. That's a tricky one. Okay, that's the hardest one today. All right. The last 2 we're going to look at. We're not actually going to solve the whole problem. I want to show you something to be careful about. Okay, in this one. What's something you might be tempted to do here, but you can't do it in this case?
Change it to exponential form.
So I'm not thinking change to exponential form. I'm thinking something keeping it in log form. Yeah, you want to combine these. Okay, usually we have 2 logs that are separate. Okay, just like we did here. Okay, we like to take the 2 logs and combine them, and that's what we did here. How come you can't do that here? The bases aren't the same. All right, so here, cannot combine into a single log because the bases are different. All right, so it's just something I want you to be aware of. So if I give you a problem on the test like this, and I say, why can't you combine these into a single logarithm? In this case, it would be because the bases are different. You can still solve it by hand. It's actually not that hard to solve. Okay. You'd have to write this with your change of base formula. Okay. So if I wanted to rewrite this, how do you write this as a fraction? Log base 3 of x. Yeah. Log x over log 3. How about this one? Yeah, log x over log 4. Now, what's the base on every log that I just created? They're all base 10. That would be your first step to solving this problem. We're not going to go any further with it. But at least if I got everything as the same base, that's a good start. So, any questions on what I just explained right here? That's all you need to know. You don't have to know how to finish this problem. All right. So every problem we've solved up until now has been doable with algebra, whether it's quadratic equation, factoring, combine like terms, all that stuff. Well, this is an equation that you can't solve with algebra. Cannot solve, at least for the exact answer. Cannot solve with algebra and get exact answer. Now, that could be really frustrating, because if you don't know that and you're trying to solve this problem, you'd spend a half hour on it. I guarantee you're not going to be able to solve it with algebra. In fact, you can prove that you can't do it with algebra. Right? But does anybody remember, like back maybe even pre-algebra, beginning algebra 1? Before you start using algebra, what else can you do when you're trying to solve things besides trying to do out all the algebra? Think of another way? Having to do with this kind of calculator? Something you could only do on this kind of calculator. Graph. Okay? Graphing is always another way to solve things. Okay? In fact, if you had taken pre-cal here, the whole book that we use in pre-cal says pre-calculus, a graphing approach. I'd say 50% of what we do is, well, close to 50% is using the graphing calculator. Okay? We do a lot of algebra, but things that we can't do or are very hard to do with algebra, we draw a picture. Right, so what I'm going to do, I'm going to draw this as a picture. X plus e to the x. And all I have to do is type it in, and the calculator knows how to draw it. I'm going to draw this as a separate picture. And now I'm basically asking where these two pictures are equal. That's kind of a weird way to say it. What does that really mean? Where the lines meet or where they cross. So if we can look at a picture and see where they cross, that would be the answer. Right? Now, even just draw this by hand, that would be pretty challenging, okay, if you don't know what these look like. The one on the right is very easy. It's just a straight line at 2. The one on the left, it kind of has this weird curve to it. All right? So the calculator can automatically tell me where they intersect, okay, which is extremely nice. So I just take a guess where I think they intersect, and then it tells me 0.44. And if you check it, that would work. Now, even the calculator, it's just estimating the answer. Okay? It's estimating the answer to 7 decimal places. And for most purposes, that'd probably be good enough. Okay? If you needed it more accurate than that, you might have to learn how to solve equations by hand without using algebra. Okay? There's things you can do by hand that are not algebra. They're estimates. Okay? And it's a process you go through. Okay? But that's not something we're going to learn in this class. What's that? I want you to know that there's other ways to solve problems besides algebra. What's that? It is. It just keeps going. So those last 2 examples, just examples of things you can't do traditionally, right? But still doable with other technology. Okay, any questions on what we did today? All right, so tomorrow we've got our test on 7.2 to 7.4. And the homework tonight, just these 9 questions. Okay, page 490, 1 to 3, 5, 6, 9, and 17 to 21, just the odds.